Hello friends, welcome to my channel. My name is Harshal. I hope your life is going good. So, now we are going to start our electricity chapter part 3rd. Yeah. So, let's start. Let's start. So, in part 1 and part 2, what we completed electric charge, electric current, potential difference means voltage, and the resistance, and some basics of resistivity. Now, we are going to complete the other basics of resistivity, more about resistivity, and heat generated and electric power. So, let's start. Difference between resistance and resistivity. What is resistance? We know the ability of conductor to oppose it, the current, and resistivity ability of material of conductor to oppose the current. This is the examples means definitions of these both terms, physical quantities. So resistance depends on area and the length. It depends on the area and length, and resistivity is not depend on area and length. It is depend on material. For example, when we took a small scaled wire and a large scaled wire, so what we can understood that resistance of this big wire is high and the small wire is low, but the resistivity is same. Why? Because the materials are same, and resistivity is only the term based on means depend on material. In the same example, second example, the material is different, so the resistivity is also different, and the length and area is same, so the resistance is same. And the in third example, the both are same because the length area is same and the material is also constant. So let's move ahead. Huh. This is the important part, means one of the important part of the electricity. Series and parallel connection. Yeah, I know in part 1 we already discussed the connections, but in this we are going to explain this in detail in depth. So, in this we can understand that in series connection the current is constant because here is I, here I stands for current. Current is moving constant. Yeah, because the bulbs are in a series. They are not divided. They are connected in a series in a one position. So the current is constant means it is same for all, but in parallel connection it is not same because here is current is going upwards in wire. It divides in three means I1, I2, I3 here. So the current is divided. It is variable in parallel connection. It is not same. I hope you will understand the difference of current level in parallel and series connection. And what is the potential difference? Yeah, means voltmeter voltage. We need three different voltage. We need three different voltmeters in the series connection because they are connected in series, not in parallel. So the potential difference is not same. It is the different in areas. Means different for all, and in parallel connection it is only common for 3, means it is common, it is only V, but here we can take V1, V2, V3. But in parallel connection it is the same, means it is not divided. All three bulbs have common. So by this we can understood that series connection have same current but different potential difference, and parallel connection have different current and same potential difference. So let's move ahead. Yeah, you can see here different. So combination of resistors. What is resistor? We know that the appliances we used in home science or in our devices, it is called resistors. For example, iron also situate resistors, bulb, etc. They all contain resistor. But when we want to do in whole, when we want to do the whole resistor, means whole resistance, total resistance, we use this formula. Let's move with me. So in this we can understood there are three different resistance, there are three different voltage, means there are three different voltmeters, but current is constant. By this we can understand that voltage, total voltage is equal to voltage 1, voltage 2, voltage 3. The sum of voltage 1 plus voltage 2 plus voltage 3. And IR also means current resistance. We can say that Ohm's law, that V is equal to IR, that is means V stands for IR. You know the Ohm's law. V stands for IR because V is directly proportional to, yeah, you are right, current. Means in IR total is equal to IR1 plus IR2 plus IR3. Why we take IR? Yes, because it is in series. The resistors are in series. So we take yes for series. Understood? I hope you will understood. Then when we put one resistor for all, then we must sum all the resistors, means 10 ohm plus 20 ohm plus 30 ohm, that is 60 ohm. So let's move to the parallel. This is resistance. Move to the resistance in parallel. You know the formula of resistance in parallel because it is reciprocal of the resistors, because the current is here divided, means it is not constant, so we take I1, I2 and I3, but here the potential difference is, yeah, it is the constant, so we take common. So R also different, means here I1, R1, R2, R3, and here also I1, I2, I3, I4, I5, I6. So when we do this, derive this formula, we can got the formula, that is I upon Rp. I upon Rp, P stands for parallel. What we got? We got 90 ohm. Yeah, in series you can remember, in series we got 90 ohm, but now in parallel we are getting 10 ohm. What we can understand by this? This formula are not important, only this is important, this last formula and these values. These values we can say that resistance in series is greater, but resistance in parallel is lower. Yeah, when the resistance in the parallel it is low and in series it is high, we calculated that current in series it is same, but in potential difference it is different, and voltage in series it is uh, different, but in parallel it is constant. So we find resistance that in series it is high and in parallel it is low. Let's move ahead. Yeah, this is now take an example of this. Means there are both this value, we find that it is in parallel and it is in serial, but what we can say that the mixed series, the mixed resistance connection, means parallel and the series connection all came in one circuit, means here is one series and here two are parallel. So by this we can understood that when the resistance come towards the series it increases its value, but when it comes towards the parallel it decreases its value. Yeah, I hope you can understood. If you understand this, like and subscribe to my channel. Now the difference between combination of resistors R1 plus R2 plus R3, 1 upon R1, 1 upon R2 plus 1 upon R3. And current remains same, but it is not remain. Voltage remain different, here remain constant. You can see. Let's move ahead. Now what is heat generated? We completed our resistivity and resistance and resistor. These three are topic. Now we are going to learn heating effect of electric current. So first understand the concept of heating effect. Then we will take the definition, proper definition. What we know, what is resistance? Remind the part to what is resistance. Yeah, the collision by the particles, different particles, the collision of different particles, different atoms by these electrons, by this flow of charge, it is known as R, means resistance. Due to resistance, what is formed? Heat is generated. Heat is formed means the electrons are in kinetic energy. When they collide the atoms, collide the different particles in that wire, the kinetic energy, it is generated in heat energy. This is called the heat generated in the electric current. Yeah, means due to the concept of resistance, it is also declared. Means when the resistance happen, when the resistance occurs, collision occurs in the wire, the heat energy is formed by the electrons when they collide to other particles and atoms. Yeah, understood? When we understood this, if we didn't understood heat generated, then we can't understand such a one numerical also. So please concentrate on this video and clear all the doubts, clear the full chapter electricity. So, electric heat generated, we take the definition, proper definition of heating effect of electric current. I know what is that. When an electric current passes through wire, here the wire gets heated and its temperature arises. When the wire gets heated, its temperature also arises. This is known as heating effect of electric current, but it is happened by resistance. If resistance didn't take part in the wire, in the electrons, the heat also didn't take part. So resistance, it is very necessary in the electricity. Now we know the formula of the potential difference, right? The formula of voltage here. V voltage is equal to work done upon charge. So by this formula we can make one formula of heat. What is that? Means when we want to find the work, means work is equal to energy. We studied this in ninth standard, that work is energy. Work is equal to any type of energy. So here is the which type of energy here is heat energy. So work is equal to heat energy. Means that we can find that here the formula is, I can zoom 1 minute. Heat energy is equal to voltage into current into time. Means when we find to coulomb, when we find to charge, the formula is I into time. So here they substitute this in the heat formula. The first formula of the heat is volt into current into time. I hope you can understood. And the second formula of the heat is I square, current square R T, means current square when the product of resistance by time. Why we take the current? Means here the formula of voltage you know. The formula of voltage you know, IR. So we substitute IR in this third formula. And the formula of IT you can say, means there are I common. We can take I common. So we took I square plus here resistance and time. Means when we want to find the resistance, we use this formula, but when we want to find the voltage, we use this formula, and when we want to find the current, we use this formula, means V square, voltage square into time upon resistance. You can understood. This is for current, this is for voltage, and this is for, yeah, resistance. I hope you cleared the three formulas of heat generated. Let's move ahead. What is this? Yeah, this I explained today. Now, how to design a heating coil? This concept we will be side. Let's complete the Joule's law. Then we will complete the designation of heating coil. What is Joule's law of heating? Joule's law of heating is that heat generated is conductor is directly proportional to the resistance. What we can understood as means when the resistance high, yeah, the current, so the heating effect also high. Why? Yes, we can say that. Means when the electrons, this is electrons that collide to the particles or the substances, atoms in the wire that produces R means resistance, and this kinetic energy due to the collision that known resistance this formed into heat energy. So we can say that heat is directly proportional to the resistance. It is also directly proportional to the square of current and also directly proportional to the time for which current is passed. Yes, passed means time square we can say. Here, heat is directly proportional to current square, it is directly proportional to resistance and directly proportional to time. I hope you will understood. Now, H, what what is this? Yeah, find to coil. How we can find the coil? Means here the question asked how to design a heating coil. So to design a heating coil, we take this. The formula of heat means I square R plus T. This is formula for remove means declaring the voltage. So heat depends on resistance means it is directly proportional to voltage resistance. So where we can say that resistance also there is a formula R is equal to rho upon length upon area. So by this we can find the coil means if what to do resistance what will be high when we increase the length and decrease the area means the width the body of wire decrease and increase the length the resistance also increase. So when the resistance increase the heating effect also increase. By this we can find the coil means we must be increase the length and decrease the area then we can produce the heating coil. Understood? Yeah, let's move ahead. Now the appliances of heating current. Did you remember the tungsten that we learned in 10th, 7th standard? Tungsten. Yeah, it is a type of element that is used in electric bulb. So why we used tungsten only? I will tell. So the heat is created means the heat is created in electric current when it is passes through that circuit. Here the heat is passes then the when heat is means when current is passed then resistance increased then but due to the resistance heat also increased. But what happens I will tell. So let's start from beginning that current is passed means here you can see the length of this tungsten wire is high and the area of the tungsten wire is low. We can see it is very thin and the length is high. So what happens the resistance also increased and when the resistance increased heat also increased. And the specialty of tungsten is that to produce heat into light to produce heat energy into light it is the specialty of that tungsten wire. So when the heat is generated in tungsten it produced into light. So we use tungsten in this bulb. But you mind a question that it can't be burnt. It can't be burned like copper, silver, or aluminium, etc. Yeah, because here is the tube-like structure. That is where the argon gas is filled. That the deoxidized the tungsten. If we didn't put a argon layered bulb it will be in 4-5 days it get oxidized. But when we put the argon gas in this bulb it doesn't burns it remain constant for 4 to 5 years. So we used argon gas and for light we used tungsten. Did you understand the structure why we use tungsten in electric bulb? Yeah, if you understand, comment. Now the other is electric fuse or the MCB. You can see that. Means why the MCB or the fuses are used in our home appliances. Why? Because in the unfavorable climate or in the running season or sometimes in disasters, the current may be flow very high or flow very low. By this, what can happen? Our AC, our TV, our fridge, oven, etc. that can be damaged or destroyed. For avoid this damage or destruction, the fuses or the MCB are located. Because the MCB means this fuses contain the PB, means the layer of lead. That what it has high low melting point. Yes, tungsten has high melting point. That's why it remains for 4 5 years in a bulb. But the bleed have low melting point, so it can be melted very easily. So when the high axis of current is passed through wire through the fuse, it is located in a wire or in the fuse when the switch off on button is located. If the excesses of current means it passes the small amount of current, but when the large amount of current passes through it get melts. Due to meltation, the wire get removed, means the fuse get damaged, and due to this the circuit breaks. Yeah, the wire get damaged, the fuse get damaged, the PB means the lead get melted. By this the circuit didn't happen and our appliances didn't burned. By this we use this PB in but now in 2019-20 we get more modernized. We use MCB, means that when the excess the magnetic effect of that fuse, means when the excess of current passes through our house, our fuse, it will automatically switches off. By this, by what? Magnet. By magnet it automatically switches off, and when the current get constant same, we will on it again. That is called the MCB switch used in our home. I hope you will understand. It is a very easy concept. By this, we can understand that heat is directly proportional to the current. It is also an example of this electric fuse. Now, electric iron we used for pressing our clothes. This is used, but this produces current and heat also. But we didn't want current. We only want heat for pressing the clothes. So that is the metal known as nichrome that passes only heats from the electricity. That passes only heat doesn't pass. Yeah, it doesn't pass electricity. And here is the mica that all heat is generated and current is generated, and this is the one type of marble or that which doesn't pass current. These are three used in electric iron. Nichrome means for giving the nichrome constant, and it is a ion it is a alloy which is made up of nickel and chromium. We can also use constantium, etc. Yes. Now, our last point of this electricity, that is power. Let's start it. What is this? The definition of this: work done per unit time. This is also example. Or energy means work is equal to energy, so energy per time or work done per time, it is known as power. So there are also three formula of this power is equal to work voltage upon voltage into current, or also current, here current square resistance, or also voltage square resistance. Means when we derivate this formula, means power is equal to current into voltage, and this is equal to current square into resistance, and this is equal to voltage square upon resistance. And let's move ahead. Yes, here is also that commercial units of the power is also kilowatt, kWh or kW, and the SI unit of power is watt. What they assign it. And the commercial process, I know horsepower means 746 watt, means 1 horsepower 1 HP means 1 HW is equal to 746 W, and 1000 watt is equal to 1 kilowatt per hour. And there are also kilowatt hour. What is this? The kilowatt hour. 1 kilowatt hour is equal to, we studied in 9th standard, it is 3.6 into 10 raised to 6 joule. It is equal for this. Here also it is given the derivation. You can read after all. These are the components that is used in electric circuit. Electric cell, plug key, wave joint, wire joint, a battery or electric bulb, a wire crossing through joining, ammeter, voltmeter, rheostat, resistance, etc. Now the all formulas, important formulas of heat, power, then voltage means potential difference, energy, current, and the resistance, resistors. So we completed our electricity chapter: electric charge, electric current, potential difference, resistance, resistivity, heat generated, and electric power. So in the next video, means that is for numericals, we completed our full chapter detailed, and now the other video is for numericals. I hope you will understand the whole chapter. So bye bye. For more videos, like and subscribe to the channel Harshalkore.